Okay, this is lesson 4, graphs of simple nonlinear functions. Okay, a function, it has the rule that each input of x is assigned an output of x squared. Do you think the function is linear or nonlinear? Okay, it is nonlinear. Because the expression has a variable with an exponent that is not 1. Okay. So now, when we do this, okay, we do not want to connect our dots, okay? So for part B here, it says, and also remember our slope formula here, okay? Develop a list of inputs and outputs for this function. Organize your work using the table below, then answer the questions that follow. So if our input is -5, okay, then, and again, we have if x equals 5, then, oh, sorry, -5. Remember, this means -5. So what we would have then is -5 in the parenthesis squared would then equal 25. And that's what you would be putting in your calculator. So -5 squared then would be 25. -4 squared would then be 16. -3 squared is going to be 9. -2 squared is going to be 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. And let me move this up so that we can all see. 4 squared is 16. And 5 squared is 25. It says plot the input and output as points on the coordinate plane where the output is the y coordinate. So now if I were to put these on the table here, okay, we have -5 and 25. So we have -5 and 25, which would be right here. Then I have -4 and 16. So that would be right here. I have -3 and 9. So that would be here. I have -2 and 4. So that would be here. I have -1 and 1, which would be here. I have 0 and 0. 1 and 1. Let me color that a little bit better. 2 and 4. 3 and 9. 4 and 16. 5 and 25. And again, please make sure, ladies and gentlemen, that you do not connect the dots here or the points on this coordinate plane. So now it says, our next question, it says, what shape does the graph of the points appear to take? It appears to take the shape of a curve. Okay. The next thing it asks us to do is to find the rate of change using rows 1 and 2 from the table. So using rows 1 and 2, we have -5 and 25, and we have -4 and 16. So using that, we have m equals, I'm going to use x1 here, and y1, x2, and y2. So we have 16 minus 25, and we have -4 minus -5. Here we've got leave change change. So now I have -9 over 1, which equals -9. Okay. And then next it says, let me move this up a little bit here. Then it says to find the rate of change using rows 2 and 3. So 2 is -4 and 16. Row 3 is -3 and 9. So again, I'm going to say x1 and y1, x2 and y2. And for that, I'm going to, again, use m equals. So 9 minus 16 over -3 minus -4. Leave change here. So here I have -7 over 1, which equals -7. And then G states, find the rate of change using any other 2 rows from the table above. Well, I'm going to use 2 nice easy points of 0, 0 and 1, 1. Here I'm going to use x1, y1, x2, and y2. So using my slope formula again, I'm going to use 1 minus 0 and 1 minus 0, which equals 1 over 1 or 1. So question H says, return to your initial claim about the function. Is it linear or nonlinear? And justify your answer with as many pieces of evidence as possible. Well, again, it's nonlinear. Because there is not a constant rate of change. And the graph is not a line. Okay. So that's our answer. Now let's look at another graph. And I showed you these in class. That first question actually was a parabola that I showed you that we've seen in class. Here we have a function has the rule that each input x is assigned an output of x cubed, or x to the 3rd power. Do you think this function is linear or nonlinear? And explain. I am going to put nonlinear. Because the expression has a variable with an exponent that is not 1. So now let's develop a list of inputs and outputs for this function. Organize your work using the table below, and then answer the questions that follow. And again, what we're going to do is if x equals negative 2.5, we put that in parentheses. So x cubed is negative 2.5 to the third power, and you're going to use your arrow button on your calculators. So you would put in your calculators parenthesis negative 2.5 parenthesis. Sorry, let me get that light. Okay. Then you would hit your arrow button. Okay. And then you would hit your 3. And then you would hit the equals. And remember, these are keys as well. So I'm going to put those in the boxes as well. Those are keys. And you've got those on your calculator, ladies and gentlemen. Okay. And then you're going to hit equals. Okay. So that's going to be negative 15.625. Negative 2 will be equal to negative 8. Negative 1.5 will be negative 3.375. Negative 1 is negative 1. Next will be negative 0.125. 0 is 0. Then we've got 0.125. We've got 1. We've got 3.375. We've got 8. And we've got 15.625. So now it says to plot, and let me move this up here. So now we are going to plot these numbers. And we are going to plot these points on our coordinate plane where the output is our y coordinate. So our first one would be negative 2 and negative 15.6. So negative 2 and negative 15.6, which would be about, or sorry, negative 2.5, I'm sorry. So negative 2.5, so probably about right here. So then we have negative 2 and then negative 8, which would be here. Then we have negative 1.5 and negative 3.3. Then we have negative 1, negative 1. So that would be about here. Then we have negative 1/2 and 0.125. So that would be about here. Then we have 0, 0. And then we have negative, or then we have a half and 0.125. Then we've got 1 and 1. And we got 1.5 and 3.3. And we've got 2 and 8. Oh, sorry, I did that one wrong. I forgot the 1.5. I knew that one didn't look right. Up there. And then 2 and 8. And then 2.5 and 15 up here. Okay. And actually that should go up just a little further. There we go. Okay. All right. Now, it says, what shape does this graph of the points appear to take? Okay. Again, it appears to take the shape of a curve. Okay. Now let me move that up, sorry. Let me copy that. So next, and again, we're going to find the rate of change from rows 2 and 3. So we've got -2, -8, and -1.5, and -3.375. So x1, y1, x2, y2. So m equals -3.375 minus -8 over -1.5 minus -2. So leave change for both of these. And that would give us 4.625 over 0.5, which would equal 9.25. Our next one for 3 and 4 would be -1.5, comma, -3.375, and -1, comma, -1. So here, so for this one, again, I just followed the slope formula. And then now for rows 8 and 9, I've got 1 and 1, and 1.5, and 3.375. So x1, y1, x2, y2. So m equals 3.375 minus 1, 1.5 minus 1, so 2.375 over 0.5 is 4.75. So again, we have down at the bottom here, return to your initial claim about the function. Is it linear or nonlinear? And justify your answer with as many pieces of evidence as possible. It is nonlinear. Because there is not a constant rate of change. And the graph is not a straight line. And even though the graph does have a constant rate at certain times, it's not a consistent constant rate of change. It is a constant rate in some parts, but it has to be consistent throughout the entire thing. Okay? So now, number 3. Okay? Function has a rule so that each input of x is assigned an output 1 over x for the values of x greater than 0. Do you think the function is linear or nonlinear? And again, remember, okay, that 1 over x is the same thing as saying x to the negative first power, okay? So this would be nonlinear. Okay, because the expression has a variable with an exponent that is not 1. Okay, so let's look into this. Okay, here we're going to start with 0.1. And by putting that in with 1 over x, it's going to equal 1 over 0.1. So when I put that in, this is going to equal 10. 0.2 is going to equal 5. 0.4 is going to equal 2.5. 0.5 is going to equal 2. 0.8 is going to equal 1.25. 1 is going to equal 1. 1.6 is going to equal 0.625. 2 is going to equal 0.5. 2.5 is going to equal 0.4. 4 is going to equal 0.25. 5 is going to equal 0.2. So now if I plot these, here we go. Well, let me put this all the way up here. So 0.1 is going to be about here and 10. 0.2 is going to be at 5, about here. 0.4 is going to be at 2.5. So 0.4 is going to be at 2.5. A half is going to be at 2. 0.8 is going to be at 1.25. 1 is going to be at 1. 1 and a sixth, so 1.6 is going to be at 6.25. 2 is going to be at a half. I'm sorry, this is going to be up a little bit. Sorry. That's a little off. Two and a half is going to be at 0.4. 4 is going to be at 0.25. 5 is going to be at 0.20. So notice how that's curving down. So again, what shape? Oh, sorry. So again, what shape is this forming? It appears to be taking the shape of a curve. So now, again, we find our slopes and our rate of change between row 1 and row 2. So we got 0.1 comma 10 and 0.2 comma 5. So y2, x2, y1, x1. And we have m equals 5 minus 10 and 0.2 minus 0.1, which equals negative 5 over 0.1, which equals negative 50. Okay. Then we have 2 and 3 here. So we've got 0.2 comma 5. And we have 0.4 comma 2.5. So y2, x2, y1, x1. We have 2.5 minus 5, 4.4 minus 0.2. So we have negative 2.5 over 0.2, which equals negative 12.5. And last, we have 1 comma 1 and 2 comma 0.5. So y2, x2, y1, x1. So here we have 0.5 minus 1 over 2 minus 1, which is negative 0.5 over 1, or negative 0.5. So again, returning to our initial claim about the function, is it a linear or nonlinear? Is it linear or nonlinear? And justify our answer. So let's do this again. Again, it's nonlinear because there is not, sorry, a constant rate of change and the graph is not a line. So now for discussion, okay? What did you notice about the rates of change in the preceding 3 problems? The rates of change were not all the same for each problem. If the rate of change for pairs of inputs and corresponding outputs is the same for each pair, then what do we know about the function? We know the function is linear. Therefore, if we know a rate of change for pairs of inputs and corresponding outputs is not the same for each pair, what do we know about the function? Function is nonlinear. Okay. What did you notice about the exponent of x in the preceding three problems? The exponent on x is not a 1. What is another way to identify equations that are not linear? If the exponent of x is not equal to 1, then non-linear. Okay, so in conclusion or closure, the rule that describes a function is given. If necessary, use a table to organize pairs of inputs and outputs and then plot each on a coordinate plane to help answer the questions. What shape do you expect the graph of the function described by y equals x to take? Well, is it a linear or nonlinear function? Okay. We expect it to take the shape of a line. Okay. And it would be linear. The exponent on the variable is a 1. So it would look like this. So it would be a line. Okay. Now for it says, what shape do you expect the graph of the function described by y equals 2x squared minus x to take? The graph, we would expect it to be a curve. Is it linear or nonlinear? We would expect it to be nonlinear. And the exponent on the variable is a 2. So in this case, it would look like that. Okay. And that concludes our lesson, I believe. Yes, it does.